Hello, dear viewers. Let's look at question 13. So in question 13, we have how many molecules are found in 6.0 dm3 of carbon dioxide at RTP. So this question came from 2019 November. Okay, so it was about the Avogadro's constant. Okay, so I hope you're able to remember Avogadro's constant deals with the atoms, molecules, okay? Yes, so it deals with atoms and the molecules. So whenever you are asked how many atoms can you occupy or how many molecules can you occupy, then you are working with the Avogadro's constant, okay? So always take note. So in our case here, we are given the actual initial. So we are given the RTP. We are given volume. How many molecules are found in 6.0? So 6.0 here, if we see it, it's the volume. And then we are given the standard, okay? The particular standard temperature. So we have RTP. Okay, so we are working with gases. So when you're finding the particular number of molecules, first of all, we find the number of moles. Because for Avogadro's constant deals with the molecules is equal to n times the Avogadro's constant, which is 6.02 times 10 to the power of 23. Okay, so take note of this. Okay, so we have this. So first of all, we have to find the number of molecules that are present. Okay, so we find the molecules and then also we find the Avogadro's constant. Okay, so in here, what we do, we first of all find how many number of moles are present. So we start with number of moles. So to find the number of moles, we look at the given initials. So you have also to know the mole table. I usually emphasize this because this is very, very important, okay? So here we have the mole table. Okay, so in here we have substances of mass, gases, and so forth. So in here we have mass, and then here we have concentration and volume, and then here we have gases. Okay, so take note that when you're in here, we can say number of moles equal to volume over molecular volume, okay? Like that. So in our case here, we are finding the gases, okay? Okay, so we can state, okay? So we put up our formula. We first of all find the number of moles. So I'll go on to calculate by using this formula. Number of moles is equal to volume over the molecular volume, okay? So the VM is at RTP. Okay, so take note that 1 mole of a gas is equivalent to 24 dm3. Okay, this is at room temperature and pressure. So when you're given RTP, we have to know that this is room temperature and pressure. Okay, so this is the standard for 1 mole of a gas. Okay, so therefore when you are trying to calculate here based on the moles that can occupy, you apply, you look at the volume given. So what are we given? So volume is already in dm3. So always remember that when volume is in dm3, we use it direct. Okay, so now we state number of moles will be equal to the volume given, which is 6.0, okay, 6.0 dm3, or you can just say 6 dm3, okay, and then over the actual standard. So our standard is 24 dm3, okay, 24 dm3 per mole, and then therefore we can go on to divide dm3, and dm3 will cancel, okay? So what will remain with, if we calculate 6 divided by 24, so I'm getting 0.25 moles. That's what I'm getting, okay? So we have found the number of moles. So upon getting the number of moles, we go on to use the Avogadro's constant. So our Avogadro's constant, which is the having molecules, we can state molecules. Okay, so I'll come this side, I'll say molecules go to, okay, so molecules go to number of moles. Okay, the number of moles, okay, the number of moles times 6.02 times 10 to the power of 23. Okay, so therefore we can apply the number of moles which we have found. So we have found 0.25, okay, moles, okay, moles, and then times 6.02 times 10 to the power of 23. Okay, like that. And then we can go on to multiply. So when we multiply 0.2 times 0.6, okay, so here we multiply this value with the 6.02, okay. So you multiply 0.25 times 6.02, okay, without including the 10 to the power of 23, we will have 1.5 times 10 to the power of 23. Okay, so here please multiply this value with the 6.02. Okay, this one is a constant. The 10 to the power of 23 means zeros which are attached to 10 to 6.02. Okay, so this is our answer. Okay, so among the option answers, our answer there is A. So we have A as our answer. Okay, so this is our answer. All right.